Now, based on these properties of gases, we will learn about a couple of laws of gases. The first law that we want to look at is called as the Boyles Law. Boyles Law is a pressure and volume law. So we will, since we learned previously that there are four factors: pressure, volume, amount, and temperature, and each of the factors will affect the gas particles. So it's kind of hard to, if you have four variables, it's very hard to study how are they related to each other. So it's important. There are two parts of the Boyles Law. The first part is that we will study the pressure and volume relationship, and the second part, which is very important, and sometimes students forget to mention this, is the temperature and the amount are kept constant. If you don't keep these two constant, there will be no relationship between these two. So you must have the temperature and the amount of gas constant, which is at a certain temperature and the same number of particles of gases. Now, from this image over here, you can see that the volume on both of them is different. And look at the pressure over here. So if you have the same amount of gas or the same particles, over here it's depicted by the same number of balls that you can see. There's 6 particles that are represented in both of them. Now notice what's happening on the first one. The volume seems to be larger, so that's why they've said it's 4 liters that has been measured, and the atmospheric pressure is 1 atmosphere. Now if the pressure is doubled, as depicted on this image B, let's call this A. When the pressure is doubled, then the volume is reduced by half. This is a relationship which is called as an inverse relationship. An inverse relationship means that as you increase the pressure, if pressure goes up, then the relationship of the volume is down. This can also be mentioned if you take an empty can of soda and you exert pressure to it, you know that the volume is going to get less. Another good example of Boyles Law is a bicycle pump. In a bicycle pump, each time when you pump or when you exert pressure on the piston, you force more particles of air, and then you exert pressure and the volume decreases. And when the volume decreases, you have more pressure inside the tube. So when you increase the piston up again, then you have more opening of the gas particles that are going in, and as because the pressure goes less when you increase, so you are able, the particles can keep on going. So there's a constant flow of the particles, but each movement is based on one Boyles Law. Another example of Boyles Law can be on breathing, and I think I have a next slide that we'll talk about breathing and see how that does take place. And over here we have another example in which we can see the scuba diver, and how does the scuba diver gets to use the phenomena of Boyles Law during an expedition underneath the sea. So coming back to the mathematical expression, a mathematical expression is drawn from this phenomena, and that is the product of P times V is always going to be constant as long as the temperature and the amount of gas is unchanged. Now this can be expressed in a mathematical expression, which is over here, and I'm going to highlight this, and usually on the test I will ask you this: what is a mathematical expression? And here's the mathematical expression: P1 V1 equals P2 V2, where 1 can be before and and the 2's can be after. So we can say the product of pressure and volume before equals the product of pressure and volume after. So you can see on this equation you would be 4 times 1 and 2 times 2, and that comes to 4. And if you apply this this mathematical equation to any gas laws, you are able to solve any of the mathematical problems. Okay, so here is another example, as I mentioned earlier, about breathing. Breathing is an excellent example of Boyle's law. Now, during inhalation, what does inhalation means? That in your inhaling, you're taking in air. When you're taking in your air, your lung seems to expand in volume. So when the lung expanding, what happens is the pressure decreases, because every time you have large volume, when your pressure decreases, air flows from the pressure outside into the lungs. Now, when you exhale, the volume decreases because the diaphragm is pulled up and it pushes the lungs, and your volume has decreased. When your volume has decreased, then the gas particles within the lung increase their pressure, and now there is more pressure inside than the outside, so the air flows from the inside to the outside. So breathing is an excellent example of Boyle's law. Make sure you know certain examples of Boyle's law: bicycle pump, or the piston, or breathing, or the scuba diver. You will have to write down one of the laws or an explanation during your exam. So now, keeping that mathematical expression of Boyle's law, we will look at certain problems or certain word problems and see how they can be solved using Boyle's law. So here is a word problem saying Freon 12, which is the formula of Freon-ton. It's a gas that is used in refrigeration system. What is the new volume? And the units for that is 8 liters. What is the new volume in liters? It's actually asking you if of an 8-liter sample of Freon gas, which was initially at 550 millimeters mercury, and the pressure has changed to 2200 millimeters mercury at constant temperature. Now, a lot of times the students tell me that they have difficulty doing these problems because there's a lot of information that's given over here. Whenever you read a word problem in the gases, try to isolate different factors. The first thing is try to find out what is constant. So if temperature is constant, then over here, since we've only done this one law, so we know that this problem is applying for the Boyle's law. However, by the end of the chapter, when we are done with 2 or 3 different laws, it becomes difficult to identify as to which mathematical expression has to be used. So now that we know temperature is constant, and it seems like there is volume and there is pressure, there are 2 things that they're talking about. So now let's try to isolate some more information out of this problem. You can see that the initial pressure is 550, and the pressure is actually this would be then P1, which is actually, this is our P1, which is our initial, and this second one is our P2. Now, let's look at the pattern between the 2. The pattern shows that now we have increased pressure. When you have increased pressure, what do you expect to the volume? It should go down. So once you have isolated all this information, you set up a table in which you isolate each of the quantities that is required. Once you have done that, it becomes a lot simpler to then apply a mathematical equation to it. So coming back to the same problem, now let's look at the mathematical expression. The mathematical expression, the equation that you must know is this one. So now that we have the 4 different variables, you can see that we needed to isolate for V2. Now, this is important that I hope everybody sort of remembers how to do that. If you don't really remember, then you need to follow up with the math lab, or come see me and I'll try to help you. So if you're trying to isolate for V2, which is this side of the equation, we must get rid of P2. In order to get rid of P2, I am going to divide both sides of the equations by P2. And if I do that, I get P2 and P2 canceled, and that gives me V1 times P1 over P2. And that's exactly what I've done. So once you have done that, you plug in the values of your quantities and you get your answer in liters. Okay. Here is another problem using Boyle's law, and in this equation, let's just try to read the problem over here again. For a cylinder that's containing helium gas, which is represented in A, or cylinder B represents the new volume. So we have two scenarios. What has happened if this was initial cylinder to go into A or B? What should happen? As you can see, the pressure have to decrease or pressure will have to increase? You can see that the first one, if the volume is reduced, then that means that the pressure must have, actually I should raise this one, the pressure, I got carried away. Okay, so when we have the pressure that the volume is showing as less, then that means that the pressure has increased. So you have increased more pressure to it and reduced the volume. On the other hand, the situation B shows that the volume has gone up, and that would be because if the pressure is decreased. Let's look at another problem of Boyle's law. In this particular problem, it's also worded, a sample of oxygen gas has a volume of 12 liters and it is at 600 millimeters mercury. What is the new pressure when the volume changes to 36 liters? Again, pay attention to this part that is given constant. This is your hint. If you find the temperature and the amount are constant, then you know that this is a pressure volume law, and the pressure volume law, the mathematical expression is P1 V1 equals P2 V2. Now if I was to do this, I want you to take a little time and think about how you would do that. You can even pause the slide over here and come back in a little while once you have done that. So do that, and I'm going to go ahead and explain it, but I want you to think about it before you keep on listening to me. Here is the first information that is given, which is the volume. So this would be my V1, and it is at 600 millimeters, so this would be P1. What is the new pressure? So that means that it is asking for P2 when the volume changes to 36 liters. So this is my V2. So now if I plug all of them in, what am I trying to isolate for? I'm trying to isolate for P2. So if I have to isolate for P2, again I must get rid of the V2 from both sides of the equation. So you have to divide both sides by V2, and this will cancel over here, which then shows that my P2 is going to be P1 V1 divided by V2. This would be the formula that you need to apply. So once you plug it in, you should then be able to find out exactly as what the answer is. So here is the solution that I just did the same thing with you, and you can check if you got the right answer, which is 200 milligrams mercury.